So far, in engineering mechanics, we know that if a force F is acting at a certain point or acting on a particle, then it can have two components, two mutually perpendicular components in the form of F cosine theta and F sine theta. This is something that you have learned at school level as well, no problem. The problem comes when there is a force acting at a particular point, and this force has to be resolved along a line AB and a line AA. This is where the problem arises. So good evening friends, this is Manas Patnaik, your friend and tutor, and in today's session we are going to decompose this force F along the line BB and along line AA. This is going to be a fun problem which I'll try to finish in the next 10 minutes, so stay with me right till the end. Here we go. Let me just give you a brief outlook as to what the given data is. There is this force, okay? It has to be resolved along line AA and line BB, okay? We've also been given that the component of this force F along line AA is 30 newtons. No issues. We need to find the original force F, its magnitude. We also need to find the component of this force F along line BB, right? Let me make some construction and let us begin. So this force is going to have two components along BB and along AA. This is how you can write it. Now we are going to use the principle of transmissibility of forces, which states that if there is force acting at a particular point, let's say this point O, let's say there is a particle over here at O, then you can transfer this force along this line of action in this fashion. You can transfer this force of 30 Newton along this line of action AA and FBB along BB. Now what we'll do is we are going to make some fine tuning. If this is force F, its component can be adjusted, increased or decreased in this fashion, okay, in order to make it or convert it into some kind of a parallelogram. Right? What are we going to do, sir? We are going to find the components with the help of sine rule, number one. Number two is we are going to use Lami's theorem. Number three, we are going to use the law of parallelogram of forces, right? These are going to be three approaches with the help of which we'll find the magnitude of FBB and the original force F. So this is going to be fun. I want all of you to stay with me right till the end. Here we go. So far so good. Okay. FBB, can we shift it over to this side? Right? The magnitude will be same. 30 Newton, shift it. So you have essentially two triangles. You can choose any one triangle of your choice and then you can simply apply the sine rule. It is going to be beautiful. Just watch. If this is 80, sir, this is also going to be 80. This is 60, this is 60, 80, 80, 80 and 60. 60, 60. 80 plus 60 is going to be 140. And for a triangle, all the three angles must be equal to 180. So 180 minus 140 will give you the value as 40. So this over here will be 40. Done. Very easy. Now what? Let's go ahead and apply the sine rule. In sine rule, please note, if these are the sides A, B and C, and these are the angles alpha 1, alpha 2 and alpha 3 or alpha, beta and gamma. A divided by sine alpha 1 is equal to B divided by sine B alpha 3 is equal to C divided by sine alpha 2. The idea is if you choose any particular side, let's say you start with F, then the angle in front of F is 40. So F divided by sine of 40 is what you are going to write. Secondly, if you choose this FBB, then the angle in front is 60. So FB over sine 60. And finally, you have this 30 Newton force. The angle in front is 80. So 30 divided by sine of 80. You just need to find out the numerical value, multiply it with 40, sine 40. You get F. And when you multiply the same with sine 60, you get FB. So these are the values. Number one. Are we done? Okay. Similarly, what we can do is we can apply the same concept, right? The same diagram can be used, but we are going to use the Lami's theorem now. Here it is. Let me just give you a brief idea. But Lami's theorem is associated with equilibrium of forces, and here we can clearly see that these two forces have this F as the resultant. If F is the resultant is not equal to 0, how can we say that this is a case of equilibrium of forces? Okay, here is a counter question. What if I keep the magnitude of force as this red color arrow that you see? If I change the direction, now are these three forces in equilibrium? Yes sir, they are, because these two forces are going to have the resultant in this direction, and you have placed this force of a similar magnitude but in opposite direction. What will this force do? It is going to counter the resultant of these two forces, right? That is FBB and 30. Now this is how you can apply or the concept of Lami's theorem. So we start with F divided by 80 plus 60, that is 140. Simple. Sine of 80 plus 60, 140. Which force is next? Sir, FBB. If FBB is the force, this is the angle that we are interested in. So over here it is 80. What about this angle, sir? Sir, this has to be 40. 80 plus 40 is 120. FBB by sine 120. Finally, you have this 30 Newton force. What is the angle? Sir, this is the angle. Okay. So that is 60. If this is 40, this also has got to be 40. 60 plus 40 is 100. That means 30 divided by sine of the angle between the remaining two forces. F divided 30 divided by sine of 100. I think we are done with this. If you do the calculation, you are going to have the same values, right? Done and dusted. Two methods, two approaches I have now explained. And finally, we are going to go ahead and look at another beautiful technique which you must have gone through in your school days. Okay, let me just, if this is A, this is B, this is resultant R. In place of resultant R, I can write F based on the terminology of the given question. A, let's say this is A, 30 Newton. Let me write this as 30 Newton. You guys have to do the calculation. FB, let's say this is FB, right? So F is F, no problem. R for the formula is F. Secondly, A in the formula is actually 30 Newtons. B in the formula is actually FB. And theta, if you watch, the angle between 30 Newton and this F is 60. 30 Newton and this F is 60. Wonderful. What about this angle? Sir, this has been given as 80. Okay, between FBB and F. FBB and F. Done. So far, so good. Now, what is the next step? So, theta is actually equal to 80 plus 60, which is essentially 140 degrees. And what we are left with is this angle beta. Angle beta is this. That is angle beta. So, beta is equal to 60 degrees. So, you can plug in all of these values, okay, into these two equations. You've got two equations and you have got two unknowns in the form of FB and F. Wonderful. Plug in all the values, solve the two equations, and you are going to get a similar answer, right? So guys, that was all from my side. If you find this content enriching, feel free to like the video and also share it with all your classmates. This is Manas Patnaik signing off. Take care and have a nice day.